In first video, we discussed what are differential equations and how they form. Then we categorize differential equations into mainly two parts, ODEs and PDEs. Then I gave you a brief understanding about ordinary differential equations. In this video onwards, I am going to talk more on ordinary differential equations. So let's move on to the lesson. This is the second video of the video series. So let's see how to classify ordinary differential equations. So what we denote by yn? Yn means the nth derivative of the function y. So if the function y forms with independent variable x, we can write yn is equals to a function consists with x, y, y prime, y double prime, and derivative of y with respect to x by n minus 1 time. This is the independent variable. These are the terms that consist of dependent variable. So nth derivative of the function y depend on the independent variable x and its derivatives which have order less than n. This is the first one. Let's see another one. How to write the nth derivative of y with respect to the independent variable t. Let's see how to write it. Yn is equals to f t y prime, y double prime, y n minus 1. So that's how we denote nth derivative of a function y. Let's see what are the important properties that we go into classify differential equations. Important properties. First one is order. The second one is degree. Third one is linearity. And then we discuss homogeneity. The first one is order. What is order of an differential equation? The order of an differential equation means highest derivative of the differential equation. Order of differential equation is highest derivative of the differential equation. Let's see some examples. First one is y triple prime plus y prime plus ex is equals to 0. In this, y triple prime is the highest derivative of the differential equation. Therefore, we call order of the ODE is 3. Right? Let's see another example. Y double prime plus 2x squared plus y prime minus 2x is equals to 0. In this, y double prime is the highest derivative. In this equation, you can see there are two derivative terms, right? This is the higher order, the higher derivative term, right? Therefore, order of the ODE is 2. The derivatives in that equation d and dy over dx. Among these derivatives, you can see the highest derivative term is this. Therefore, the order is 4 because y differentiate by 4 times, right? Therefore, the order is 4. But in this case, y differentiate by x only 1 time. So I think you can understand how to classify differential equations by order. Let's see how to classify differential equations by their degree. So the new topic is degree. Classification based on degree. Degree means the power of highest derivative term. Derivative term. Let's see an example. First one. So first identify what is the highest derivative term. So what is the highest derivative in this equation? There are two derivatives in this equation, d squared y over dx squared and dy over dx. Among them, this is the highest derivative. So its power, see in this equation, the power is 1, right? Power is 1. So we can say the degree is 1. Let's see another example. So in this equation also there are two derivative terms, right? What are the derivatives in this equation? dy over dx, d squared y over dx squared. This is the highest derivative in this equation. And let's go to the equation. What is the power of the derivative? Power is 3. Power is 3. So degree is 3. But you can see this term's power is 5. But it is not the highest derivative term. Highest derivative term is this. Highest derivative term is this. You have to take the power of the highest derivative. So degree is 3. So let's talk about a special case when derivative terms as fractions, like derivative terms in numerator. Let's see an example. In these types of cases, you can't say the highest derivative is this and the power is 1, right? In these types of cases, we have to multiply it by both sides by e squared y over dx squared to make the numerator free of derivatives, right? We multiply it by whole equation d squared y over dx squared. We can get y dy dx plus right, we can get this. So the highest order derivative in this equation is d squared y over dx squared, right? This derivative is in two terms in this equation, so in this term and in this term, so it doesn't matter. The order is 2 and degree is 1 because the powers are 1 in both terms. That's all for this video. I think you can find the order and degree of a differential equation by these things, right? I'll see you in next video.